our next one here. Another fun regular polygon for the base. I'm going to start this first by identifying what pieces of information I have. So here, this time I have the height of the pentagon is 7 inches, and this time they're giving me the side length of the pentagon rather than like the slant height. So first thing I would probably do in this situation is start by finding the area of the pentagon, the base. So I'm just going to redraw the base as best I can. And I see that the bottom here is 4 inches. We're going to start by dividing up into our triangles. Finding the measure of the central angle, 360 divided by 5 is 72 degrees. And then remember that when you cut out your right triangle, that both the side length and the angle are bisected. Okay, so instead of being 4 inches, the base of this is now going to be 2 inches. Instead of being 72 degrees up here, it's now 36 degrees, 72 divided by 2. Because I'm looking for area, I'm interested in finding the height of the triangle or the apothem. If you want to call it H or A, I don't care. Either way is fine. Once I do that, I notice that this is not a special right triangle, so I'm going to be using sine, cosine, and tangent. I'm going to identify the pieces that I have. So from the 36 degrees, I see that this is the opposite. This is the adjacent. So O and A means tangent. I'm going to go ahead and say that the tangent of 36 degrees is equal to the opposite over the adjacent. You can substitute in tangent 36 or keep it all the way through. Either way is fine. I'm going to substitute since I know a lot of people tend to do that. So 0.7265 over 1 equals 2 over A. You're going to cross multiply. And then you're going to divide out the 0.7265 or the tangent of 36. So I get that the apothem is going to end up being 2.7, I'm going to say 5 inches in this scenario. So that represents the height of the triangle, which you can label in this diagram here. If I'm going to continue on finding the area of the base or the area of the pentagon, I'm going to say 1/2 because it's a triangle times go back to the full base. So now we want to use that 4 inches times the height we said was 2.75. And then I'm going to multiply by the fact that I have 5 triangles in a pentagon. So the area of the base or the area of the pentagon is going to be 0.5 times 4 times 2.75 times 5, which is approximately 27.53 inches squared. Okay, now that's just the area of the base. We now need to find the lateral area, right? The area of all of those triangles. And then this is where it can get kind of more complex. So I'm interested in finding the lateral area. So I need to find the slant height. If I make that right triangle here, I need to figure out what that missing segment is. Well, if you look at the pentagon, do you see how it's the apothem of that pentagon on the bottom? So the apothem, go back to our math. We said that the apothem was 2.75, which we solved for down here. So what I'm going to do is keep that 2.75 here, and I'm now going to be using Pythag because I have a right triangle here. I'm going to do a squared plus b squared equals c squared. So I think what I might do is just draw this off to the side. And I'm going to say 2.75 squared, the apothem, plus 7 squared should equal the slant height squared. And it's okay if you round and get some rounding error when you're doing your homework. That's to be expected. When I solve that out, I get a slant height of about 7.52. And then from there, I'm going to shift into looking at a different triangle. So we solved that this was 7.52. Notice that the base is going to be regular, so that's going to be a 4. So now if I cut out this green triangle here, we have a slant height that we solved for was 7.52, and then the base here is 4. So when I'm solving for the lateral area, I'm going to do 1/2, because the lateral area on a pyramid is a triangle, of course, times the base is 4, times the height is 7.52. And then you want to make sure you multiply by the fact that how many triangles are on this figure. Well, if the base is a pentagon, there's 5 different triangles. So then I'm going to solve that out. 0.5 times 4 times 7.52 times 5 gives me 75.2 inches squared for the lateral area. And then my last step, as always, is to add the base area and the lateral area to get the surface area. So I'm going to take the area of the pentagon, which we said was 27.53 approximately, and add in 75.2. So my final surface area when I add those together is about 102.73 inches squared for my final surface area. Once again, if you get some rounding error, like you're slightly off, that's just fine. It's to be expected. And then we're going to shift over into our next example. We have a pyramid and a 55-degree angle inside that triangle. So if you're getting an angle measure inside of a pyramid, it's very likely that you're going to be doing some trig to solve for missing pieces. So if I take out this triangle that they drew in for me, and what I'm going to do is just cut it out, I see that 29 is the height of the triangle. This is 55 degrees. I need to find the slant height, which is on the outside on those triangles. I'm going to label that L, as well as this side right here, which I'm going to call B for base. You could call it whatever you want, though. Once I do that, if I'm given a non-special right triangle, so in this case I'm given a 55-degree angle, I'm going to start by labeling what the individual pieces are. So this is the opposite, this is the adjacent, and this is the hypotenuse. I need to do 2 trig problems. The first trig problem is going to solve for, let's say, the base, and the second one's going to solve for the slant height. So if I'm solving for the base, I'm going to say it's O and A, which would make it tangent of 55 degrees is equal to the opposite over the adjacent, which in this case is B. You're going to end up having to divide that out. So it's going to be 29 divided by the tangent of 55. And that's going to give me about 20.31 feet for that one. Looking at my slant height, I'm going to be using opposite and hypotenuse, which is sine. So I'm going to say the sine of 55 degrees is equal to the opposite, which is 29, over the slant height, which is L. Opposite over hypotenuse. So that's going to be 29 divided by the sine of 55. Gives me about 35.40 feet. So if I go back and look at this figure here, I just found this slant height to be 35.40 using trig, and I found this part of the base, the whole base, to be 20.31. So when I'm going to take out the triangles for the lateral area, I want you to go ahead and notice that the lowercase b that I solved for is actually half of the full base. So when I take out that triangle here, it's upside down, I'll flip it right side up. I noticed that the slant height we said was 35.40 feet. I want the full base. Now notice here that the base only represents this length. I also need to get this length as well. A square is the only figure out of all of the regular polygons where you're allowed to just double it. Otherwise, you have to do some more math in terms of the base of the polygon. But here I'm just going to double it, and I'm going to say that that full base is going to be 20.31 times 2, which gives me about 40.62 roughly. So this base is 40.62. Now notice that it is a square on the bottom, so all of these side lengths here are going to be 40.62 all the way around. So for the lateral area, I'm going to do 1/2 because it's a triangle times the full base is 40.62. And then I'm going to do times the height, which is 35.40, and then times how many triangles I have. So there's 4 triangles on that pyramid because the base is a square. So when I multiply that out, I wind up getting 2,875 roughly. And I'm getting 0.90. Once again, depending on how you rounded, you might be getting something slightly different. But you should always double check your work. I'm good to go. So that's going to be feet squared. That's for the lateral area. I also need to get the area of the base. Notice that the base is a square. And we said that because one side was 40.62, all of them are going to be the same because notice that there's hashes down there. So I'm going to do base of the square is going to be 40.62 times the height is also going to be 40.62. So I'm going to multiply that by itself, and I wind up getting 1,649.98 feet squared for the area of the base. And then last step, I just need to add those two. So my final answer for surface area is going to be 2,875.90, which is the lateral area plus the base area. And that gives me a final surface area of about 4,525.88 feet squared. And that should wrap up everything for surface area of pyramids and cones. Thank you so much for watching.